Hello all, and thank you for listening to another video of, whoa, I can't talk today, of Mr. Laxton talking through these 5.4 notes for Algebra 2. Complex numbers is what we're looking at today, and gonna be honest with you, this is kind of a long section, so I'm gonna try to get right into it here. Complex numbers are imaginary numbers. We're going to talk a lot about what those are today, and they're for quadratics that don't have any real solutions. So they're actually imaginary numbers, and we're going to talk about what those guys are today. Awesome. So here we go. Looking into some quadratic equations have no real solutions. All right, that's what this guy is here. It says no real solutions. This occurs when you're trying to solve an equation by taking the square root of both sides, and you have a negative constant term. Okay, so notice here, if I have this, if I end up with x squared equals -1, if I take the square root of both sides, these guys cancel out. We talked about that in the last section. Now I end up with plus or minus the square root of -1. Notice, if I have the square root of -1, if I look at, remember that the square root has to be the same number, so if I go 1 times 1 equals +1, -1 times -1 equals +1. So there's no negative, there's no way to get a negative number underneath the square root if you're multiplying it by its same number twice. So to account for this, as you guys see here, math geniuses came up with the imaginary number I. Okay, so we look at I, you say, hey, I is it's a vowel, it's a letter in the alphabet, and now in math, I is a number. So I is the square root of -1. So circle, highlight, do whatever you need to do with this guy to make that important to you. I is the square root of -1. All right, that's going to be important. All right, so now as I look to fill these guys in here, I is the square root of -1. All right, I squared, if we look at that, that's going to be the square root of -1 times the square root of -1, which actually in math, and this is kind of one of the trickier ones, I squared is going to be -1. Okay, that's going to be huge. We're going to use that a lot today, that I squared is equal to -1. All right, I cubed is going to be what? The square root of -1 times the square root of -1 times the square root of -1. That is going to be the square root of -1, which is I again. All right, so I cubed is the same thing as I. And then I to the 4th power is actually going to be I squared times I squared, which is -1 times -1, which is equal to +1. All right, so I to the 4th is +1. I squared is -1. This is going to be the kind of the big deal here. I squared is equal to -1. That's going to be kind of the most important thing that we're going to look at today. I squared equal to -1. All right, awesome. So these square roots of negative numbers, we can deal with these just like we dealt with the square root of positive numbers. We got to simplify them. But the first thing here is that if I look at the square root of -4, remember I kind of like to work these down here, you always break out the square root of -1. Because now I know the square root of -1 times 4 gives me this -4. All right, so always break out that square root of -1. And then now we just talked about what is the square root of -1. The square root of -1 is I. So now I have I times the square root of 4, but I know that the square root of 4 is 2. So this kind of just turns into plus or minus 2I. All right. Awesome. So now I have the square root of -8. So the square root of -8. Always break out what first? Yes, you got it. We got to break out the square root of -1. So now I have the square root of 8. So now I know that the square root of -1 is I. The square root of 8 breaks into the square root of 4 square root of 2. And I know the square root of 4 is 2. So I'm just going to kind of put that 2 out in front. So it's plus or minus 2I square root of 2. All right, so that's what we get there for the square root of 8. All right. Oh, excuse me. All right, as we move on to solving quadratics with imaginary solutions, the same deal as what we were working on the other day, except for now we're going to have square roots of negative numbers. So now, hey, I got to get this x squared all by itself. So I subtracted 12, So now I have 2x squared is equal to what? -20. And I know that here I got to divide by 2, so now I have x squared equals this negative 10. I got to square root both sides, so now I have x is equal to, and then now I have to simplify that square root of negative 10. So remember, hey, you always break out that I, that's the square root of negative 1, and then you have the square root of 10. And we look here, square root of 10 can't be simplified. There's no perfect squares that go into that. So the square root of 10 is all you got. All right, so this is your final answer. All right, I guess I should toss a plus or minus on there just to make for good measure. All right, here we go. Minus the 3 to both sides. Minus that 3, so now I have 1/3 x squared is equal to negative 9. Multiply by the reciprocal, so these guys go away. Multiply by 3 over 1. So now I have x squared is equal to negative 27. All right, and here I have the square root of negative 27. I got to square root both sides, so I get x equals, remember here I'm just going to break out that I, and then we have the square root of 9 square root of 3, because I know that the square root of 9, or 9 goes into 27, and 9 is a perfect square. All right, so here we go. The square root of 9 I know is 3, so I'm going to break that out in front. It doesn't have to be, so I have plus or minus 3i square roots of 3. All right, awesome. All right, good. Complex numbers in standard form. We're going to look here is that there's going to be kind of two parts. There's an imaginary part and there is a real part, a pure imaginary. All right, so as I look here, complex numbers in standard forms, they have a real part and an imaginary part. So they're in this form right here, a plus bi, and that's probably a good thing to circle, highlight, do whatever you need there. A plus bi. If b is not equal to 0, then a plus bi is an imaginary number. All right, so that's like an example would be like 3 plus 2i. So b is not equal to 0. That's what we call an imaginary number. All right, so if a is equal to 0, this is what we call a pure imaginary number. Imaginary. All right, and that would be an example like if a is 0, then it'd be like, I don't know, negative 3i. Is it a pure imaginary number? All right, so here as I move on here, a complex plane is a coordinate plane that has a real axis in the horizontal and an imaginary axis in the vertical. So here's what it looks like. We have a x, most of the time we have like an xy, but now this is my real part and this is my imaginary part. All right, so you walk over left and right, whatever is your real, and you walk up and down, whatever is your imaginary. So that's what this guy, you walk the real part first, left and right, the imaginary part second, up and down. All right, so that's just a quick couple examples here that we have on the next part of the notes here. It says graph the following. I'm just going to call these guys like A, B, and C, and D to kind of just go through and talk about what these guys are here. All right, so I'll label them on here for you. All right, so A, as I look here, my A for A is 6 and my B is negative 4. So this point is going to be 6, negative 4. All right, this point right here, as I look at my A is 2, my B is 2. So this point is going to be 2, comma 2. My C here, as I look, let's call this an I right here. All right. So that number in front of that I, if it's not there, is a 1. So my point is negative 3, comma 1. All right. And this guy right here, my A is negative 2 and my B is negative 5. So I have negative 2 and negative 5. All right, awesome. So here my A is 6, negative 4. So I go over 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So that is my A point. My B point is 2, 2. So 2, 2. You said 2, 2. That is my B. Awesome. And my C is what? Negative 3, 1. So negative 3, 1. That is my C. And my D is negative 2, negative 5, which is right there for my D. All right, awesome. So just find that a and that b part, a plus or minus bi. Find out what those letters are. Walk your a first and your b second. All right, complex numbers, we're going to do some adding, subtracting, multiplying, and dividing of these guys in the next little part here. There's not a whole lot different than adding and subtracting, just kind of just polynomials. All right, it's not going to be a whole lot different here. Really, when we're adding and subtracting, we just have to combine like terms. Okay, so here we go, add or subtract, so these guys are being adding, so that's nice. So I add like terms, so I have my 5 and my 2 are like terms. I combine those guys to make 7. My 3i and my negative 4i are like terms. Those make plus a negative 1i. All right, so 7 plus a negative 1i. If you want to have minus 1i, that's fine too. All right. The second example, notice, is a subtraction. And what we like to do, if you remember back to all the way back to chapter 1, is we like to make this into plus, and then everything after it turns into the opposite. So these guys are both the opposite of what they look like. All right. So now I have to just combine like terms. Now this is just an adding problem. So I have negative 2 plus negative 3, which is going to be negative 5. And then my i's, I have 1i plus a pi, oops, Siri, I don't need you there, is plus 7i. All right, so just combining some like terms there, we like to add the opposite. All right, multiplying complex numbers, you FOIL or distribute the same way that we do in multiplying algebraic expressions, excuse me. So here for this guy, we just distribute this 2i onto both these guys, or excuse me, the negative 2i. So negative 2i times 4 is going to be negative 8i, and then negative 2i times a negative 6i is going to be a positive 12i squared. All right, and remember here that I squared, if I look back on the front part of my notes, I squared is always equal to negative 1. So never can you leave I squared in your answer. You always have to make I squared into negative 1. So now this turns into negative 8i plus 12 times negative 1. And that just turns into negative 8i minus 12. All right. Awesome, great, fine, dandy. So whatever that I squared term is, that really just turns into the opposite. So it started at positive, now it goes into negative. All right, awesome. The next example is where we actually have to FOIL these. I have a binomial times a binomial. So FOIL these guys if you like to make your marks, that's great. 3 times negative 2 is negative 6. 3 times negative 2i is negative 6i. I times negative 2 is negative 2i. And then I times negative 2i is going to be negative 2i squared. All right, awesome. So now we can combine like terms, make these guys into that I squared deal. So here, negative 6i and negative 2i make negative 8i. So I have negative 6 minus 8i. And then this turns into negative 2 times. Remember that I squared is always negative 1. All right, so here this is going to make this a positive 2, so I have negative 6 minus 8i, and then now I can combine like terms one more time, is that negative 6 plus 2 is going to be negative 4, so I have negative 4 plus a negative 8i. All right, so these guys can combine like terms at that point. All right, awesome, awesome, awesome. So here we are moving on to the next one, complex conjugates. All right, so this is going to be key when we actually divide, because we don't like i's in the bottom of our fractions, just like we don't like radicals in the bottom. All right, so these complex conjugates are going to be the exact same here. Notice that this is a plus bi, and what do you notice is the only difference? That this one is a minus bi. All right, so the only difference is this plus and this minus. So the complex conjugate actually turns out when you multiply these guys, it makes a real number. All right, so now if you notice here, these guys are complex conjugates. One's plus, one's a minus. All right, I'm going to erase those before we go in and FOIL these guys. So now if I actually FOIL these guys in together, 7 times 7, 49. 7 times 4i is going to be 28i. All right, negative 4i times 7 is going to be negative 28i. and negative 4i times 4i is going to be negative 16i squared. Okay, and this, hopefully you should kind of see this now, is that what happens to my i's? As I notice here that my i's cancel each other out. It's negative 28 and positive 28i. They both cancel each other out. So now I have 49 minus 16, and then remember my I squared turns into negative 1. So this is going to be negative 1. So this is going to be 49 plus 16. So we know that, hey, 49 plus 16 is 63. So again, if you multiply something by its conjugate, it turns into a real number, and that's going to be key for us today. Okay, and that's how we're going to divide complex numbers. So dividing complex numbers, we are going to use the complex conjugate of the denominator to make that into a whole number. So I'm just going to do example number 1. I'm going to skip example number 2 just for kind of sake of time in this video here. So I have to multiply the bottom by its conjugate. So what is the conjugate of the bottom? It is 4 plus 2i. All right, and if I multiply the bottom by 4 plus 2i, I have to make sure, hey, you got to multiply the top by 4 plus 2i. All right, and then now this is kind of where this is kind of a long problem, is that now you have to FOIL the top and FOIL the bottom. So now as I notice, I just kind of like to do the bottom first, is that 4 times 4 is 16. 4 times 2i is plus 8i. Negative 2i times 4 is going to be negative 8i. That's what we want because these i's are going to cancel out. And then 2i times negative 2i is going to be minus 4i squared. Okay, awesome. Now the top is not going to cancel each other out, so that's, or it might, but not necessarily. We'll have to see here. So now if I look at 6 times 4, that gives me 24. 6 times 2i is going to be plus 12i. As I look at here, negative 3i times 4 is going to be a negative 12i. Look at that. I have my i's in the top that cancel out as well. So not every time is it going to work like that, but sometimes it does. So now here I have negative 3i times 2i gives me a negative 6i squared. All right, awesome. So here we go. Notice that here the i's cancel out on the top as well. So what we have left on the top is 24 minus 6 times negative 1, because that's what my I squared turns into. And on the bottom we have 16 minus 4 times negative 1. All right, notice that's what my I squared turns into is negative 1. Okay, you guys aren't going to forget that. That's going to be ingrained in your brain. All right, so now here I have 24 plus 6. And on the bottom I have 16 plus 4. All right, 24 plus 6 is 30. 16 plus 4 is 20. And then I can just simplify this fraction. I can actually just take away those zeros, take out 10 out of both those guys, so it's 3 over 2. All right, so again, not every time is the I is going to cancel out on the top and on the bottom, but it needs to cancel out on the bottom. All right, so that's the reason why we do that, is because we want to make a whole number on the bottom or a whole real number without any i's. All right, here we go. These absolute value of a complex number. This is actually just kind of a quick, easy little formula here. Is that z is equal to the square root of a squared plus b squared. So remember here that, hey, we have my a, we have my b. So here I have an a and I have a b. So I have z is equal to the square root of my a, which is 3 squared, plus my negative 4 squared. Okay, so here I have the square root of 9 plus 16, and I know that 9 plus 16 is the square root of 25, and I know that the square root of 25 is plus or minus 5. All right, and it's actually the square root of that. So we're just looking at that plus 5 there. But there we go, complex numbers and absolute values. It's just really just plugging it into that formula, that z equals the square root of a squared plus b squared. All right, so that's what the absolute value is there. All right, awesome, great. Thank you for listening to that. I know that was a lot of information. We're going to work a lot with complex numbers. That's going to be a key thing throughout this chapter and throughout this year. So please make sure you come find me if you have any questions, and we will see you later.